Okay, so let's look at example number 5, which is a word problem dealing with exponents in a way. So a chessboard has 64 squares. If 1 grain of sand is placed on the first square, 2 on the second, 4 on the third, and so on, with the number of grains doubling each time, how many grains of sand would be on the 64th square? So let's look at this. So to solve this, the first thing to do is actually I want you to kind of maybe draw, to make life easy. Draw your boxes. So I'm gonna come back here and draw my box here and say, well, this is my square. Of course, I'm not gonna draw 64. Maybe I'll draw up to 5. And this is box 1, 2, 3, 4, and 5. And let's see. So here they say a chessboard of 64. So I'm gonna go all the way up to 64, right? But I'm not gonna worry about the 64 one. If 1 grain of sand is placed on the first box, so the first box I'll put 1 here, right? 2 on the second, uh, on the first, 2 on the second. So this will have 2, 4. I'm gonna double it, so this will be 8, and obviously this will be 16 on like that. So this will be 32 like that, with the number doubling each time. How many grains of sand would be on the 64th square? So you cannot draw this all the way to 64. That will completely take all the time that you need in the test. So you need to figure out. The first thing you want to do is whenever you see things doubling, they're generally going to follow this equation like that. Generally, when things are doubling, when they are tripling, it's going to follow this like that, right? When they are tripling, it's going to follow things like that. So since they are doubling, it's going to follow one of these, 2 to the power something. So obviously, it's not going to have 64 because, it's going to have 64, then the first one will have 1, the second will have 2, the third one will have 3. So this one is gone, and it's not going to have 64 square. That doesn't make any sense. So let's look at these two. Most students will pick this one, but if you pick this one, then that means when x is equal to 1, is going to be 1, and then when x equal to 2 is going to be 1, 3 is going to be like that. So you cannot do this. If you do y is equal to 2 to the power x, that means when x is equal to 4, x is equal to 4, y is going to be equal to 2 to the power 4, which is not true, because that is actually 16 here. All right, so let's play with this. When y is equal to 1, sorry, when x is equal to 1, we have 2 to the power 1. Nope, so that will not work. This will not work, right? If you take this answer here, that means when x is equal to 64 and you do y is equal to 2 to the power 64, that means every single x value will take its corresponding value. But it appears not to be true, because as we plug in x is equal to 1 here, so here y is equal to y1 is supposed to be equal to 2 to the power 1, which is equal to 2, but it turns out it's equal to 1. It's reducing by. So let's come back here. So y2 is equal to 2 to the power 2, which is equal to 4, and that's 2. So there's something wrong. So let's come back here and see. Means the 64th one is going to go down by 1. So obviously the x will decrease by 1. So let's play with this model that y is equal to 2 to the power x minus 1 and see if that works. So y1 will be equal to 2 to the power 1 minus 1, which is equal to 2 to the power 0, which is equal to 1. That's true. It works here. How about y2? So y2 is equal to 2 to the power 2 minus 1, which is equal to 2 to the power 1, which is equal to 2. It works here also. Let's try y3. y3 will be equal to 2 to the power 3 minus 1, which is equal to 2 to the power 2, which is equal to 4. It works. Let's play with 5. So y5 is equal to 2 to the power 5 minus 1, which is equal to 2 to the power 4, which is equal to 16. That also works. So obviously you can see clearly that this here is your answer. So the equation for this is equal to y is equal to 2 to the power x minus 1. X has to go down by 1 for you to get this graph. That is how this graph is set up here.